Crash course on computer science, algorithms and problem solving. Explore algorithms and problem solving techniques that are essential in computer science. Welcome to your crash course on computer science, algorithms and problem solving. In this article, we'll explore algorithms and problem solving techniques that are essential in computer science, provide some interesting stories and examples, list and describe the top 12 popular algorithms, and wrap it up with a poem about the beauty of algorithms and problem solving. Part 1: Algorithms and Problem Solving. An algorithm is a set of instructions that solve a problem or accomplish a task. In computer science, algorithms are essential because they allow programmers to create efficient and reliable software. There are many problem-solving techniques that are used in computer science, such as divide and conquer, dynamic programming, and greedy algorithms. These techniques help programmers break down complex problems into smaller, more manageable parts, and find efficient solutions. An interesting story about algorithms involves the creation of the first algorithm. In the 9th century, a Persian mathematician named al-Khwarizmi wrote a book called Kitab al-Jabr wa al-Muqabala, which introduced the concept of algebra and the algorithm. The word algorithm comes from the Latinized version of his name, algorithmi. Al-Khwarizmi's algorithm was used to solve linear and quadratic equations, and it was a breakthrough in mathematics and computer science. Part 2: Top 12 Popular Algorithms. Now let's move on to the top 12 popular algorithms and their target problem domains. 1. Sorting algorithms. Sorting data in ascending or descending order. 2. Searching algorithms. Finding specific items in a collection of data. 3. Graph algorithms. Solving problems related to graphs, such as shortest path or maximum flow. 4. Divide and conquer. Breaking down problems into smaller subproblems. 5. Dynamic programming. Breaking down problems into smaller subproblems and reusing solutions. 6. Greedy algorithms. Making the locally optimal choice at each step to reach a global solution. 7. Backtracking. Finding solutions to problems by exploring all possible options. 8. Branch and bound. Finding the optimal solution to a problem by exploring a tree of possibilities. 9. Randomized algorithms. Solving problems by using randomization. 10. Approximation algorithms. Finding a good solution to a problem when the optimal solution is not feasible. 11. String matching algorithms. Finding patterns in strings of characters. 12. Computational geometry algorithms. Solving problems related to geometric shapes, such as finding the intersection of two lines. Let's dive into more detail about some of the top 12 popular algorithms. Sorting algorithms. Sorting algorithms are used to sort data in ascending or descending order. Some popular sorting algorithms are: bubble sort. This algorithm compares adjacent elements and swaps them if they are in the wrong order. It is not very efficient, but it is easy to understand and implement. Quick sort. This algorithm is based on the divide and conquer technique. It picks a pivot element and divides the array into two sub-arrays, one with elements smaller than the pivot and the other with elements larger than the pivot. It then recursively sorts these sub-arrays. Merge sort. This algorithm is also based on the divide and conquer technique. It divides the array into two sub-arrays, sorts them, and then merges them back together. It is more efficient than bubble sort and quick sort in most cases. Searching algorithms. Searching algorithms are used to find specific items in a collection of data. Some popular searching algorithms are: linear search. This algorithm simply iterates through the array and checks each element until it finds the desired element. It is not very efficient for large arrays, but it is easy to implement. Binary search. This algorithm is more efficient than linear search. It works by dividing the array in half repeatedly until it finds the desired element. Graph algorithms. Graph algorithms are used to solve problems related to graphs, such as finding the shortest path or maximum flow. Some popular graph algorithms are: Dijkstra's algorithm. This algorithm finds the shortest path between two nodes in a weighted graph. It works by assigning tentative distances to all nodes and updating them if a shorter path is found. Bellman-Ford algorithm. This algorithm also finds the shortest path between two nodes in a weighted graph, but it can handle negative weight edges. It works by relaxing all edges in the graph repeatedly. Dynamic programming. Dynamic programming is a technique used to solve problems by breaking them down into smaller subproblems and reusing solutions. Some popular dynamic programming algorithms are Fibonacci sequence. This algorithm is a classic example of dynamic programming. It generates the Fibonacci sequence by adding the two previous numbers in a sequence. Longest common subsequence. This algorithm finds the longest subsequence that is common to two given sequences. It works by breaking down the problem into smaller subproblems and reusing solutions. In conclusion, algorithms and problem-solving techniques are essential in computer science. They allow programmers to break down complex problems into smaller, more manageable parts, and find efficient solutions. The top 12 popular algorithms target different problem domains, such as sorting data, searching for specific items, or solving problems related to graphs or geometric shapes. By understanding and implementing these algorithms, programmers can create efficient and reliable software. Part 3, Summarizing. In summary, algorithms are essential in computer science because they allow programmers to create efficient and reliable software. Problem-solving techniques such as divide and conquer, dynamic programming, and greedy algorithms help programmers break down complex problems into smaller, more manageable parts, and find efficient solutions. The creation of the first algorithm by Al-Khwarizmi was a breakthrough in mathematics and computer science. The top 12 popular algorithms target different problem domains, such as sorting data, searching for specific items, or solving problems related to graphs or geometric shapes. Part 4, a poem about algorithms and problem solving. And now, a poem about the beauty of algorithms and problem solving. In the world of computing, algorithms reign supreme, solving problems, big and small, with solutions that gleam. From sorting data to searching strings, and finding the shortest path, algorithms are the key to making technology last. Divide and conquer, dynamic programming, greedy algorithms, and more. Problem-solving techniques abound in this world of computing lore. From Al-Khwarizmi's first algorithm to the present day and beyond, algorithms will always be a crucial part of computing's bond. So let us embrace the beauty of algorithms and problem solving and unlock the power within. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html?aid equals 7989335 as a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our AnHub Metaverse channel, and please watch more interesting videos here.